All right, today we're tearing down an architectural blueprint for something that honestly sounds a little bit like magic. We're talking about a way to prove you created a piece of digital work without actually showing the work to anyone. It's a wild idea that could totally flip the script on what digital ownership even means. So let's dive in.
I mean, just think about that for a second. How on earth can you prove you own something without revealing what it is or even who you are? It sounds like a riddle, right? Well, this single question is the entire reason this blueprint exists, and answering it gets to the absolute heart of digital privacy and ownership.
So here's how we're going to break it all down. First, we'll look at the big picture, the mission. Then we're going to pop the hood and check out the Rust back end. That's the engine. After that, we'll jump into the cockpit, the React front end. Then we get to the really cool part, the AI and cryptographic magic that makes it all tick. And finally, we'll see how this whole blueprint goes from a plan to a real-world thing.
Okay, first things first. Before we get lost in the weeds with all the tech, let's talk about the why. What is the fundamental problem that this whole system is trying to solve? Let's get into the mission.
The entire project is built on this idea called a local-first application. And the best way to think about it is this. Imagine you're writing in a private journal versus, say, a Google Doc. The journal is yours. It's on your desk. It works even if your internet is out. You and only you decide who gets to see what's inside. That is the core principle here. Your data lives on your device. You are in complete control.
So the mission really boils down to these four key ingredients working together. First, everything is local first, keeping your data safely on your own machine. Second, it uses an AI model to analyze your work and find its unique style, kind of like a digital fingerprint. Third, any licenses or permissions you create are kept completely private or off-chain. And finally, a tiny, rock-solid, verifiable proof of all this gets publicly stamped onto a blockchain. But, and this is the key, it does it without revealing any of your secrets.
All right, let's pop the hood and get into the engine room. This is the back end, built in Rust, and it's where all the serious number crunching and heavy lifting happens. It's the power behind the entire operation. Think of this as the schematic for the engine. Everything is organized in that commands folder. That's the main control unit. When a command is fired, it might talk to db.rs to fetch something from your local database, or it might ping olama.rs to ask the AI for an analysis. And when it's time for the really complex crypto stuff, it calls on zigmojo.rs to generate the proof. It's all neatly compartmentalized.
And inside that main folder, you basically have three key jobs that get done. The register command is what you use when you want to log a new piece of work into the system. The license command is for when you want to create one of those private permission slips for somebody else. But the star of the show is prove. That's the button you push to kick off that whole incredible process of generating a verifiable secret proof.
So if the back end is this powerful engine tucked away, then the front end is the cockpit. It's the dashboard, the control panel. This is where you, the user, actually sit down and interact with all that power humming away under the hood.
And that cockpit is laid out pretty simply. You've got the author dashboard, which is basically your home base where you can see and manage all your work. Then there's the license issuer, a specific tool for when you need to grant someone a license. And maybe most importantly, you have the license verifier. This is the part that anyone in the world can use to check a proof and confirm it's valid, all without ever getting a peek at your private work.
Okay, we've seen the engine, we've seen the cockpit, now it's time to talk about the magic. This is the really mind-bending part of the blueprint, the privacy-preserving core that makes this entire thing possible. This is where AI and some seriously advanced cryptography come together.
At the heart of it all are two highly specialized tools. The way to think about it is like this. The Zig tool is like a high-tech notary public. It takes a fingerprint of your work, bundles it with your public identity, and puts a digital stamp on it. That's the commitment. Then the Mojo Prover acts as the inspector. It can look at a license and confirm it's legit based on that original notarized commitment, all without ever opening the envelope to see the private details inside.
And this gets to the core idea of something called a zero-knowledge proof, or ZK proof. It's a game changer. You're not telling someone the password. You are simply proving beyond a shadow of a doubt that you know it. The system can ask you a question that is mathematically impossible to answer correctly unless you possess the secret. So you prove your knowledge without ever revealing the knowledge itself. It's brilliant.
So how does the proof actually work?
Well, the real genius is in the separation of information. On the left, you've got your public inputs. This is the stuff everyone is allowed to see. The author's public ID, a scrambled hash of the work, things like that. But on the right, you have the private witness. These are your secrets, the actual license, your private keys, all the stuff you never ever show anyone. The system then uses your private secrets to mathematically prove that all the public stuff is true and correctly linked together. It's an incredible cryptographic dance.
And that proof happens in 4 lightning-fast checks. Step 1, the system asks, are the keys of the person holding this license actually valid? Check. Step 2, okay, was this license actually issued to them? Check. Step 3, and this is the big one, does this secret private license perfectly match the public fingerprint on the blockchain? Check. And finally, step 4, did the original author actually sign off on this whole thing? If the answer is yes, 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 and yes, the system spits out one word, true. The proof is valid. Done.
So you see, this isn't just some abstract academic idea. The blueprint gives us a really clear step-by-step roadmap for taking this concept and turning it into a real, functioning application that people can use.
And that path to a live app has 5 clear steps. You start by implementing those core crypto tools we talked about. Next, you set up and configure the AI model that's going to find those unique author fingerprints. Then you fire up the main application itself to get the user interface and the local database running. And finally, you take it all live by hooking it up to a public blockchain like Solana and building a secure way for users to manage their keys.
And that right there is what's so powerful about this. It's not just a vague concept. Every single piece is defined. It's a complete start-to-finish guide for building a new kind of application, one where users are finally in control of their own data and their own digital creations. And that really brings us to a fascinating final question. You know, this blueprint is designed for code and art, but the principle behind it is huge. If you can privately prove you own a piece of software, what about your academic research? What about your private medical data? What about your very identity itself? This architecture, it might just be a glimpse into the entire future of digital trust.